Okay, we're going to do our last day of conic sections. So what we're going to do now is we're going to talk about conic sections in standard form because that's the way that you're going to see them most often. And by standard form, we mean y equals, you've seen standard form like of a parabola before, ax squared plus bx plus c. Okay, your conic sections are similar, it's just there's a lot more terms. So we'd have an ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Okay, those are all the possible terms you could have when you expand out a conic section that's in graphing form. It's definitely possible for some of them to be 0, but you would definitely have A and C not equal to 0. One of them can be, but A and C cannot both be 0. Okay. One thing that I would encourage you to do with this is make a Desmos graph where you have this in standard form, your ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, and just kind of mess around with it a little bit and like maybe even check your answers with it. I can just kind of show you one thing that would happen here. Right now I've got it's set up, it's an ellipse. Okay. What really defines what the conic section is going to be are A and C. Okay, and we'll talk about that in a second. But you can set something up like this and just kind of use the sliders and experiment a little bit. One thing you can see right now is that my eccentricity is close to 0, right? C over A. It's kind of, I shouldn't say close to 0, but it's small. Okay, 1/5. So if A gets closer to -2, that eccentricity is going to get closer and closer to 1. Okay, and so we see our vertically aligned parabola here, ellipse, getting more and more like a circle until it is a circle. And then we switch to this horizontally aligned ellipse. And then you might be able to guess that as we get to A equals 0 is when we reach a parabola. And then think for a second, what do you think is going to happen once A moves into the positives? We've got hyperbola. And if we keep going with that, it changes the alignment of the hyperbola. Okay, so, and I can do that slider for that. And you can kind of see all the conic sections, right, just by changing that A value. Okay, the one thing that we're not going to change is B. Not that you can't, but if you change B, it rotates. And we're not going to have any of those. Okay, same thing with any ellipse. Like it's almost easier to see with any ellipse. We don't want those. We're going to have it perfectly vertically aligned or horizontally aligned, and that occurs when B is 0. Okay, so we'll use that to check some of our answers as we go. There are some rules. Okay, first of all, A and C cannot both be 0. But again, I mentioned it. Your conic section is determined by these values for A and C. Okay. First thing, well, let's do all 3 of these, or all 4 of them, I should say. A could equal C. We could have A times C is greater than 0. But again, that would only if A and C are not equal. So, it's possible for them to be equal and the product to be greater than 0. We're just say if they're not equal to each other, okay, but A times C is greater than 0. That could also mean A and C could both be negative. Okay, and then another case would be A times C is less than 0. So they have opposite signs. And then the last one is A times C equals 0. But keep in mind, they can't both be 0, so that just means that one of them is 0. Okay, you can probably pause right now and kind of guess which each of these give you. Okay, remember your choices are, we have parabola, ellipse, hyperbola, and circle. Okay, if you want, go ahead and pause and see if you can guess what the right answers are, how to match these up. Okay, I'll give you the answer right now. A equals C, you have a circle. A times C is greater than 0, you have an ellipse. Less than 0 would be a hyperbola. And equal to 0 would be a parabola. Okay. So it sounds easy. That's all good, right? But the problem is that's not always true. This is true unless dun 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 it's degenerate. Degenerate. Okay, if it's degenerate, it's not gonna be any of those. Okay, I mean if it's degenerate, it's a degenerate ellipse or a degenerate hyperbola. Okay, or whatever. So we're going to do some examples. We're going to check them with graphing, and we're going to discover some that are degenerate once we try to check them with graphing. Okay, so the examples that we're going to do are in your PDF, your Master Math Mentor one. So I'm just going to, we've got A equals 2x squared plus 3y squared plus 4x minus 5y plus 6 equals 0. We have b, which is 9x squared minus 9y squared minus 3x minus 2y plus 3 equals 0. We have c, x squared minus 4x minus 2y. If you want to just fast forward till I'm done writing these down, that's fine. d y squared minus 2x squared minus 3x minus 8y minus 5 equals 0. E, 2x squared plus 6x plus 2y squared minus 8y minus 3 equals 0. And F, x squared plus 10x plus y squared minus 8y plus 100 equals 0. Okay. All right. For each of these, we're going to write down what A and C are. Okay, so A is what comes before x squared. So A is 2, A is 9, A is 1, A is negative 2. Tried to trick you there a little bit, writing it out of order. A is 2. A is 1. Okay, now we're going to write B. So for this one, B is 3, B is negative 9, B is 0, B is 1, B is 2, and B is 1. Okay, so now we just go to our rules. Okay, this first one, not equal. When I multiply them together, it's positive, so we would have an ellipse. Okay, second one, not equal. When I multiply them together, it's negative, so I would have a hyperbola. Okay, next one, B is 0, which means this is going to be a parabola. Next one, the product is negative, so we'd have a hyperbola. Next one, they're the same, so we'd have a circle. Next one, they're also the same, so we'd have a circle. Okay, so those are all the right answers unless it's degenerate. Okay, easiest way to tell if it's degenerate, again, just graph it. Trickier is you'd have to complete the square, and I'll show you that too. But first, we'll figure out which ones we need to do that for. So we're going to graph all of these using our little Desmos tool here. Okay, so starting out with A, we would have A was 2. Yeah, it's 2x squared. Always skipping the b. In fact, I'm going to delete that so I don't have to keep skipping over it. And I'm going to take it out of this expression up here. Okay? All right. 3y squared, 4x, negative 5y, and then f would be 6. Okay. And we see already have a degenerate one. Okay, what happened there? You might have noticed that before I changed f, it worked. You were able to see it, the ellipse that we were expecting. And There you go. See that? We had any lip, but something happened to make it degenerate at some point. Okay, so we will go back and look at that one a little bit and show how you could tell from the equation that was degenerate. And it's not super easy to tell. You have to complete the square. Okay. Let's move on to B, though, which we said would be a hyperbola. So our 9x squared minus 9y squared minus 3x minus 2y plus 3. Oops. Okay, there's the hyperbola that we were expecting, and it's not degenerate, so we got it. Okay, C, we have 1x squared, 0y squared, minus 4x, minus 2y, oops, I already had it there, plus 3. We've got our parabola, as we had suspected. Okay, so we're good with that. Next we have D, and we have negative 2x squared, 1y squared, negative 3x, negative 8y, and F would be negative 5. And again, I hope I didn't lose you. We're just graphing the same ones that we answered over here. Okay, so we're on D right now. Okay. And we suspected a hyperbola for D, and that's what we're seeing, that upper branch up there. Okay, we've got a hyperbola. Okay, next one, we're going to do E. So we've got an E, we've got 2x squared plus 2y squared plus 6x minus 8y minus 3. Okay, so we've got a circle for that one. Looks good, just like we suspected. And then our very last one. Oops, what did I just do? Okay, our very last one, we have 1x squared plus 1y squared plus 10x minus 8y equals, oops, F was 100. Uh-oh, where'd that one go? Okay, so that's another one that we're going to look at here in a second. Okay, so we need to revisit A and F. All right. So something happened with those, and I'm actually going to delete the other ones so I can do some work here. So we're going to take this stuff. Oh, I'm just going to erase it. Thought I could box it out, but I guess not. Okay, and then we're going to take that. So we can just look at A and F. Nope. Okay, I'm going to move F up though. Okay, so something happened with these, and I kind of already let you know they're degenerate, but we're going to see how we could have picked up on that. Just use black. Okay, so we're going to start to get it into graphing form. So for our ellipse, we're going to have our 2 factored out of our x squared term and our 4x. And then 3 factored out of our y squared term and our 5y. And then the negative 6 on the other side. Okay. Split your middle term. And when we complete the square, that means that we added something. We're going to figure out what we added. Okay, and don't forget those coefficients. So on this side, we added 2. Okay, and then the y's, we added, let's see, 75/36. Or we can reduce that, 25/12. Okay, so we have 2x plus 1 squared plus 3y minus 5/6 squared. And you can probably figure it out what happened. 25/12, that's roughly 2, right? Okay, this is 2 and 1/12. So for negative 6 plus 2 is negative 4. Negative 4 plus 2 and 1/12, that's negative 1 and 11/12. I did my math right there, right? 4 and a 12th of that, yeah. Okay, so what happened here is there are no xy values that make this equation true, because we will get a positive term from the squaring, a positive term from the squaring. There's no way we could get a negative value. Okay, so that's what made it degenerate. We come up with an equation that no xy pairs actually make it work. Okay, so we can just kind of practice here with our other guy. I'm running out of fun colors. Let's see. We'll do dark blue. Okay, so over here, let's see, we've got x squared plus 10x, so that'd be x plus 5 squared, y minus 4 squared equals negative 100 plus whatever we added on. Okay, so we've got x squared, and you can see, what's probably going to happen there is that we're not adding on more than 100, right? X squared plus 10x plus 25, and so that would be at 25. And then y squared minus 8x plus 16. So we added on a 16. Okay, so we added on 41. So we have x plus 5 squared plus y minus 4 squared equals negative 59. Okay, so another equation that just won't work. So we have a degenerate ellipse in part A and a degenerate circle in part B. Okay, now the reason that we need these and that I've had you working on these is because of Calc 3. Okay, so I'm going to stop here and I'm going to make a second video for how you're going to see these used in Calc 3. Okay.